Trigonometry functions are very important because they have a lot of properties. This video will not really explain a problem at first and then explain how to solve it. This will just be a lot of information. So, what were our trigonometry functions again, or what did they mean? Suppose we have a triangle like this. We have a side over here and one over here. And this triangle has a 90-degree angle. Let's call this point A. We have here point B and here point C. And let's call this angle over here, let's call this alpha. Now, what do our trigonometry functions say again? We have our sinus function of the angle. And if you want to calculate the angle, this is proportionate to the opposite side divided by the hypotenuse, AB. For your cosine of an angle is the same or is proportionate to the adjacent side, AC, divided by AB. And we also have the tangent function of our angle, which is the opposite side, BC, divided by the adjacent side, AC. Now, these functions are important for the next bit. But first, let's draw another triangle. And this is a very specific triangle where all sides are the same and every angle or every corner here is also the same, 60 degrees. Well, what if we want to do the same thing, want to create the same triangle, however this time we want to have an arc like this, where this is also length of 1. Well, this angle, as you can already see, is not exactly 60 degrees. It's a little bit lower. Instead of degrees, so this is not 60 degrees, this is a little bit smaller than 60 degrees. We do not use degree anymore to explain this angle. We call this radians, where this is called 1 rad. And it's just saying that this is exactly the angle if this length was 1, if this length was 1, and we create an arc of also length 1. Now, if we were to create half of a circle, so let's do that. Create half of a circle, and the circle is specific because its radius is 1. So if we were to create in this circle 1 rad, so this distance is exactly 1. This is called 1 radian. Then we can have another one here, which is also 1 radian, and this piece here has also the length of 1. Then we have the same thing here. This is also length 1. Not really, my drawing isn't really proportionate, but these are all length 1. All these arcs, this one is length 1, this one is length 1, this one is length 1. All these arcs have a length 1. However, as you can see, we're missing a small piece here. One small piece, and we're interested in what the length of this arc is, because then we know how much radian half of a circle is. And it turns out that this length of this specific type of this arc is 0.1415, etc. Meaning that if we add up all the radians of half a circle, we actually get to pi, 1415, etc. Meaning that if we would even draw the whole circle, it will be 2 pi radians, 2 pi rad. So that is also where the whole notion of pi came from, of half of a circle, of specifically the unit circle, and with the unit circle meaning it is a circle with radius of 1. And the length of the arc of the circle, of half the circle, is exactly pi. Well, this is great. Right now we have degrees and we have radians. It's very easy to calculate from radians to degrees and from degrees to radians, because we can use the proportionality, because we know that 180 degrees is equal to pi. So if we were to ever calculate how much, for example, 45 degrees is, all we have to do is look at the proportionality and know that 45 times pi divided by 180 gives us how many radians this is. Well, you don't really calculate pi with decimals, you just leave it as a symbol, because this is the same as 45 divided by 180 times pi, and 45 divided by 180 is the same as 1 over 4. So actually 45 degrees is the same as pi divided by 4, or 1/4 times pi. So that is how you can calculate from degrees to radians, and in the same way from radians to degrees. Radians are used in a lot of applications, also in a lot of spectral units, which we will also use later in this course. Now, why did we need the sine, cosine, and the tangent and these radians? Well, let's take a look at a quarter of a circle. So I'm going to draw a quarter of a circle here. My drawing skills aren't perfect. Like this. So this is half a circle where its radius is, of course, again 1. Now, let's say that we have a point here. And the point is point P. And our middle point is point M. This is a point on our circle. We want to traverse the circle. And let's say we have a whole circle, but I just have drawn a quarter of it. So if we have this circle, I actually want to know where my point P is. We could even say that this is on the y-axis and this is on the x-axis. And our point M is in our coordinate system at 0.0. And this point here is at, of course, at point 1. And this point here is point 1, meaning that this distance is 1. Like that. Well, you get the idea. This distance is 1. So we have a point P on this quarter of a circle, and we would like to know what its coordinates exactly are. If point P was exactly at this point, its coordinates would be 0.1, and if point P was exactly at this point, its coordinates would be 1.0. However, point P is somewhere in between. How do we know what its coordinates are? Well, luckily for us, we have our trigonometry functions, because if we draw a line from point P directly downwards, we actually create a triangle. And there's something very special about this. We have an angle here. Let's call this angle theta. If we take the sine function of theta, what did we need? Well, the sine function always said we have the opposite side, which is let's call this point here. Let's call it point S. Sine of theta is actually the same as PS divided by PM. But PM is special because our circle has a radius of 1, because that's how our circle is defined. So actually, the sine of theta is equal to PS. And in the same way, if you look at the cosine of theta, it is the adjacent side, namely MS, divided by the hypotenuse, which is in our case PM. However, again, PM was equal to 1, so the cosine of theta is equal to ms. And if we look at point P, ms, right here, actually is the x value of point P. And if we look at PS, it actually is the y value of point P. So the sine actually, if we take the angle of our point, we actually get back the y value if we take the sine of that angle. And if we take the cosine of that angle, we get actually the x value. Our tangent, of course, is just the opposite side, so that is PS divided by the adjacent side, which is ms. And this is just a ratio and nothing more special than that. And this is very good. And for some specific angle values, we actually know what these x and y values should be. And there's a table which is very important to memorize. So here we have our sine function of theta, we have a cosine of theta, and we have a tangent of theta. And we're also looking at a quarter of a circle, because if we know it for a quarter of a circle, we can actually extrapolate it to a whole circle very easily. We look at an angle of 0. Above it I will write in degrees, so this is in degree, and this is in radian. For 0 degrees, for 30 degrees, for 45 degrees, for 60 degrees, and for 90 degrees. In radian, this is equal to pi over 6. This is equal to pi over 4, pi over 3, and pi over 2. If we look at a sine, our angle always starts at the x-axis. So if we look at our quarter circle again, this is our starting point. Our angle here is 0. So if we have an angle of 0, what is our y value of the purple point right now? Well, our y value is 0. And at 90 degrees, it will be 1. For the cosine, it's exactly the opposite. At an angle of 0, our x value will be 1, and at the 90 degrees, it will be 0, because at 90 degrees, the purple point will be up here, if we look at the quarter circle. So, now it's just filling in the values in between, and these values, I'll give them to you. They can be calculated specifically, but for now, I'll just give these values, and you just have to memorize them. This is a half. This is a half square root of 2, and this is a half square root of 3. And for the cosine, it's exactly the opposite. It's a half square root of 3. Here it is a half square root of 2. So at 45 degrees, it's exactly in the middle, and the x and y values are the same. And for 60 degrees, the x value is a half. For the tangent, you would think that these values aren't really that necessary. However, they are very handy if we go to the next video about polar forms, where at 30 degrees this ratio is 1 over square root of 3. Here it is 1. Here it is square root of 3, and here we get to infinity. If you ever forget these values of the tangent, you can just simply divide the sine by cosine, because tangent was PS divided by MS. But PS was equal to our sine, and MS was equal to our cosine. So tangent is actually equal to the sine of theta divided by the cosine of theta. Now, quickly some other remarks. If we look at this x and y value, or these x and y values, or the values that the cosine and sine give us, let's say its maximum is always 1 and its minimum is always -1. If we look at our sine function, let's make that green. So we have a sine of theta, and our x-axis is represents the angle theta, and our y-axis here represents the value that it outputs. So you could call it, well, it's x or y depending on looking for cosine or sine, but just the output of the function. So let's just call it output. If we look at the sine function, at 0, we are at 0. And then we go up, and we go to -1. And then we go to 1 again. And then we go back to -1 again. And it's periodic because we can go over the circle many, many times. At this point, this specific point, because we get back to 0 again, this is at pi. And this point is at 2 pi. And this point here is at 3 pi. And this point here, just outside of the axis, is 4 pi. Because at if we look at this half circle, we knew that half a circle was pi. So that means if we go pi further every time, what is the y value? Even better to visualize this if we draw the whole circle on the axis. So we have an x-axis and y-axis, and let's see if we can draw a circle here. It's more of an egg right now. Close enough. If we look at these values, we know that this is 0, an angle of 0. This here is an angle of half of pi. Then we look at an angle towards here. This is an angle of pi. If we look at the next one until here, this angle is of 1.5 pi, or 3/2 pi. And lastly, we have a whole circle which we already defined as 2 pi. So an angle of 2 pi is the same as an angle of 0. It repeats itself. As we can see here to the left in our function, we see that at 2 pi, right here, it actually goes back in what it was at an angle of 0. It just repeats itself over and over again. And if we walk through the circle, we see that at an angle of 0, our y value is 0. At an angle of 1/2 pi, it is maximal, it is 1. So at this point here, it is 1/2 pi. And at this point here, at its lowest, then it will go to pi. And then after that, when the y value is -1, it is 3/2 pi, or 1.5 pi. Then we go further and we just add 1/2 pi every time. So here we have 2.5 pi. Here we get to 3.5 pi, etc., etc. Now for our cosine function, cosine of theta, the cosine actually starts at 1. Then at 1/2 pi it is 0. We'll continue to pi, then back to 3/2 pi. At 2 pi it is maximum again, and it will go into the same period over and over again. And even as right now, as you can see, they are very, very similar, which is true because we can rewrite both functions into each other with the following property, that our sine function of theta is the same as a cosine function of theta minus pi over 2. So we shift the function a little bit to the right. And the same is for the cosine of a theta value is actually the same as the sine value of that theta plus 1/2 pi. It's just shifting our sine function a little bit to the left. One more thing. is because we talked a lot about complex numbers, instead of talking about x and y plane here to the right of our nice x circle, we can actually see this as that this is our real axis in the complex plane, and our y is our imaginary axis. Instead of from that our x value here is 1, well, it's still 1, but our y value isn't 1 here, it's actually I. And then goes down again to -1, and then bottom here is -I. Nothing else changes, it's just that the sine represents the imaginary value and the cosine represents the real value. Furthermore, another very important property, because of this triangle here with our quarter circle, if we look at this, we know that PS was our sine and MS was our cosine. So if we follow the rules of Pythagoras' theorem, it means that PS squared plus MS squared is PM squared. PM is 1, so 1 squared is still 1. PS squared is sine squared, so sine of theta squared, plus cosine of theta squared is 1. So if these angles are the same, sine squared plus cosine squared is 1. And this is a very important property. So this was everything about trigonometry, which is very important, which will be used in the next video about polar forms, and it will be used a lot in the next videos as well, because the whole course revolves around these periodic functions, about these sinusoids, about these waves.